what we are going to discuss in Git is like what is the version control, what is the source control management system, and why we need it. And we are going to talk about why version control is important. And there are two kinds of version control systems available. That is, one is called central and distributed. We'll talk about that and advantages of using it. And we are going to talk about the terminologies on the Git. Okay. And then what is a Git lifecycle, how to push and pull it, and what is the branching strategy and how do I use that. We'll see an example of Git branching and merging. And then what is the rebasing concept, why we needed that. Okay. And then next is the tags. What is Git tags and how do we use it? So basically it will be related to the releases. Okay. And next is we'll talk about Git patch and do it. And then we will talk about the Git stash. Okay. These are all the concepts we are going to talk about. And here we are going to use GitHub as our centralized repository. So that is a distributed version control system. We'll talk in detail about that. When we talk about software development, okay, collaboration is one of the critical feature which is needed there. Like multiple developers will be working on the same set of code. Okay, so I cannot just keep the source code on a shared location and then everyone will come and start writing into that, right? That is going to create me a lots of trouble in managing the code. Let's say I have a developer, two developers working on the same set of code. And if they are modifying the same line of code, I should be able to notify, like there should be a tool which helps me to merge the two codes. I cannot be manually going inside the file and copy pasting the respective code and manage it. That's going to be really a painful job for me. And if there is a same on the same line, if I'm having different content, let's say I'm defining a module called a test and inside the test, I'm creating a, let's say I'm just doing some activity, like I'm loading a one variable and the same other developer is loading another variable for the same variable. Okay. So I will have a conflict coming into picture. I should have a system which helps me to manage all these things, right? So that is where source control management system was. Linux is the biggest open source project and Git was developed by the guy Linus Torvalds. Linus Torvalds is the guy who wrote Linux, right? So
Yeah.
he was working with multiple developers across the globe. For him, it was a nightmare to get the code and integrate it. Okay, so this guy has invented the Git tool. Okay, so that it will be easy for him to get the updates from the open source developers across the globe. So he has invented Git, and that has now become very popular, and everyone is migrating towards Git. Okay, so SVN is kind of very rarely, like old technologies, people use SVN, and Microsoft has its own concept of Git called TFS. There also they started to give the Git wrapper to it, and you know that recently Microsoft acquired GitHub. Okay, so they are going to migrate everything to the Git based scenario. So now I would say like in next 5 or 6 years, the only source control management system will be Git based. Okay, nothing else is there. So that is where the source control management system comes into picture. So it actually, the Git made Linus Torvalds' life very easier in getting the updates on the code, on the Linux code, which is being given by the multiple developers across the globe. Okay, so when I talk about source control management system, okay, so what are all the basic features I would be looking for in a source control management system? Okay, so one is I should have a centralized authentication and authorization mechanism, right? So in a source control system, you will have multiple repositories. So only the person who was working on the code, for him only I should be giving as a write access. For others to come and read that in my organization, if there are some other developers who want to come and see my code, I should give them a read access to them, and I should not give them write access to it. Okay, so I need to have a proper authentication. And another important requirement in the source control management system is called as the version control system. That means, imagine I'm writing a code today. Okay, and suddenly I'm making some, okay, let's say I'm having it as a version 1.1. Okay, I'm making some changes, let's say version 1.2, and there is some issue in my version 1.2. I should be able to go back to the version 1.1 in a very quicker fashion, right? So uh, that is not really possible if you are managing it with this individual file. Like I need to understand, okay, what are the areas? I need to track what are all the files I modified. I need to go and comment them. All those things I need to do. So I need, if there is a tool which can provide me a version control where it can automatically maintain versions and I'm allowed to go back to the previous version, that is going to be really helpful, and that is what the source control management tools are going to provide for every commit. Okay, we'll go in detail about commit and hashing concept and other things. So every commit it is going to maintain a version and I'm allowed to go back to any version possible and I can track the revision history. So what are the things done on that, which of the files are modified, all those things I should be able to see this. Okay, and then next important thing in the version control is like, so first we talked about collaboration, next is authentication and authorization, this is then is the maintaining the version control of it, and next is the like I should give them a different areas to work. At the end, I should be able to collate everything as a single source code and I will deploy this. Let's say on a module, there are 10 developers working. They should be working on 10 different branches and there should be a mechanism. All the 10 branches can be merged easily and the final source code can be generated. So this is where the version control system comes into picture. So why version control system? First is single source of truth. That means you are not keeping the source code on multiple places. On a centralized location, you are having the source code. And next is code collaboratively. Like multiple developers can work on a single code. And next is it should allow me to maintain versioning and then I will be able to restore previous version. And next is the backup. That means imagine I'm writing my code on my laptop crashed. So I need to have it in a centralized location so that I can retrieve the code and I can use it. So backup is another requirement. And next is develop remotely. I don't need to log into the server on my laptop. I can develop a code. And once my code is ready, I can push it to the centralized users. And next is manage users, like who can do what kind of things on the repository. I can do that. And next is file level permission. That means I can specify this user can write something on this file. Like for example, I say, okay, this developer should not modify the configuration file. They can just modify the code. So those kind of permission access I can provide. And next is the traceability. That means imagine there is some issue happening on a particular piece of code. I need to identify who developed this part so that I can go and understand what is this design behind it is and how do I use it. So traceability is also another important factor on the on the SCM. And next is you can reduce the duplication, right? So if you have a centralized area, people can go and browse your existing Git repo. And if there is any component which I can use it, I can reuse it. I can reduce the duplication effort and then do the DevOps right. So I should allow the uh, people to collaborate it. Okay. So this is why you need a version control system. And there are two kinds of version control system available in the market. One is called as the centralized version control system and another one is called as the distributed version control system. Okay, so I talked about SVN, right? SVN is a example, a tool works on a centralized version control system. So the problem there in the centralized version control system is like you will be logging on to the server and there you will be making the changes. Let's say if I have 100 users who are connected to the version control system, my server should be having a capacity that it can handle 100 users concurrently and they will be working on the server directly in a remote mechanism. Okay, but that is going to create me a lots of problem in my thing. Like I need to have a very high capacity mission for the centralized version control system. Okay. and it is a single point of failure. Like for example, if the centralized version control system is down, all my developers cannot do anything and they have to sit idle. Okay. And in case if the data getting lost on the centralized version control system, the data will be lost until unless you have a backup mechanism configured. So all those things, it's going to be a problem in the centralized. So that is where the distributed version control system comes into picture. That is what Git is, the distributed version control system. So what really happened in the distributed is you will be coding, writing your code on the local, and there will be a staging copy which will be stored on your local machine. And when you decided to, okay, finally I'm deciding, okay, my code is ready. It's okay to push it to the centralized system. You will push it until unless it doesn't need any communication with the centralized system. That is on the GitHub. I don't need every time I don't need to be connected to the GitHub. Only when I do a push and pull, I will be connecting to the centralized system. Because of this, you don't need a high capacity Git servers. And there is one backup available on your local. So even in the data loss scenario, imagine you don't have any backup configured for your Git. Ideally, people will be configured backup, but on the worst case, if you don't have backup, the code copy will be available on the developer machine. From there, you can collect it. So this is called as the distributed version control system. And in our lab, we are going to concentrate only on the distributed version control system, where the code will be written on the local machine. And only when I'm doing a push and pull, I'll be connected to the Git server. Otherwise, I don't need connectivity to the Git server at all. Let's talk about the advantages of Git. So as I told you, it's open source, okay, and it's free to use. And another major advantage is it doesn't need a huge server, and even the Git client is very small inside. It is not going to impact any performance. Okay, it is very fast and small. And another advantage is it is the implicit backup. I told you, right? Even if the Git server goes down, you can get a copy from the developer machine. Okay, and then security wise, it is lot better because Git communicates to the server. Git client communicate to the server in two protocols. One is called as the SSH protocol, like where the communication between the client and the master is completely encrypted, and another method is HTTPS. So you can connect to the server via two protocols. One is HTTPS and SSH, and both are secure and no need for powerful hardware. And branchings are lot easier. With a single command, you can create a branch, and with a single command, you can merge it back to the master. So these are all the advantages of the Git. And next thing, let us talk about the terminologies which are used in the Git. Okay, so normally I told you, like in Git, there will be a temporary area, and whenever you commit anything, it will be stored in the temporary area. And when you do a push or a pull, it will send to the Git remote repository. So normally you will be writing your code on the working directory, and then you will issue a command called git add. Okay, git add will prepare the files which needs to be committed, and then git commit will commit the code into the staging area. Okay, and when you do a git push, it will push the code in the staging area to the Git remote repository. So this will be the normal order, like where you will do a git add and then do a git commit. Commit will store the code in the staging area. When you do a git push, it will push it to the centralized repository. Okay, if you want to pull the latest code from the centralized repository, that is called as git pull. Okay, so these are all the terminologies. Okay, and next is I will talk about that in blobs and tree in detail once you install the Git client. Okay, in the staging area, how the files are getting stored. Okay, so these are stored in the concept called blobs. You might have heard about this in the database concept. So it will not be like a readable file. Okay, you cannot go there and then read the content of the file in the blob structure. And these blobs will be created in the .git directory. I will talk about that. Okay, and next is called tree. Tree is like in your source code, you will have a directory structure, right? that directory structure will be stored as a tree. Okay. And there is one more concept I want to talk about, hash algorithm. So let me explain you the hashing algorithm. Okay. So normally hash is something like when you apply, imagine like you have a source file. Okay. When you run a hash algorithm, it is going to generate a unique identifier in the world. Okay. This will be almost 64-bit character, if I remember it correctly. So there will be a alphanumeric code will be created for it. And for the file globally, the hash value will be very much unique. So the other file will not have the same hashing algorithm. This concept is being used in the signature concept. In the digital signature concept, they will create a hash file, hash value, and on the receiver end, they can create a hash value and compare both of them. And if the file is being tampered in the transmission, the hash value will differ. And based on that, they will decide whether the actual file is tampered during the transmission. Okay, so this is the concept. So hashing is the algorithm on a source code on any file. If you run a hash, and that will be unique in the world, and if the file is modified, the hash value will change. So Git also uses the hash algorithm. When you store a source code, a hash value will be created for the source code, and that hash value will be stored as a commit ID. So on Git, every commit, whatever you're doing, the versioning I'm talking about, right? So it is managed with the commit ID. We will see that while installing the Git client and how the commit ID is getting generated. And using that commit ID, it is going to manage the versioning of the source code. Okay, so you might have seen this in while downloading the applications from internet. Like when you download application, so they will also provide that SHA1 hash value. So you can download the file and generate a hash value, hash for the file. And when you compare, if they are both are same, you can be sure that the application is not tampered in the middle. Okay, so this is the same concept used in digital signature. The same concept is used in Git. For your source code, a hash value will be created, and that hash value will be your commit ID. Okay, we will see that in detail when we install the client. And next is the branching strategy. I talked about when a developer is working on, like I want to create separate branches for every developer, I can create it, or even the branching strategy varies from organization to organization. Like let's say some organization may have that in production, I have a different branch. The test code, I will have a different branch. So once the testing is successful, they will merge the code from test to the production branch. So those kind of things, we'll talk about the branching strategy. And next is called as the clone operation. Clone operation is something, imagine you are new to your team and you want to download the existing code, then you will use the git clone. Git clone will download the complete repository onto your local machine. Okay. And next is called a git pull. So clone is a bit different from the, pull is different from the clone, where clone will create the complete copy of the repo and pull will only download the difference. Okay, so normally it will be like first you will do a git clone, and after that, if you do a pull, whatever the changes available on the master, only the changes will be pulled onto the remote. That is your workstation. And next is the git push. Git push refers to if you want to push your local code to the centralized repository, then we will call it as a git push. And next, there is one more thing is called as the head. Head always refers to the latest commit of the particular branch. For every branch, there will be a separate head will be available. And I will show you these files, how it is available in the .git directory. So inside that you can see it. Head always refers to the latest commit of the particular branch. So blob is the actual file storage, tree is the directory structure, and commits are the hash value of the particular version of the source code. And branches, you can create multiple branches, and then clone will copy the complete repository onto your local. Pull will just pull the difference. Push will push the code to the centralized repository. And here also I want to highlight, push will only send the difference. It will not try to push the complete repository, and head always points to the latest commit of the repo.